Today we will be talking about the Cloudiod project, and this is the application code. This application code is a Flask JSON API service, which is a client-server architecture service, using Flask to provide two JSON APIs. One is the root API for testing, and one is for the object detection, which is API/object detection. And this endpoint will receive this CC4 encoded image, and using this do YOLO task function to execute the YOLO image object detection, and this function will return a list of objects filtered, and this list will then append to the result object, and it will, in conjunction with the ID, return as a JSON object using JSONify library. And the web service is created running using this Python code, and this application.python will be run by this line of script, which runs the Flask web application on 5,000 ports. The Docker file will be the Docker file will be the Docker file creating the Docker image using the docker build command. This Docker image will be based on the Python 3.8 Slim Buster image, and firstly it will add some files into the content image, and then install a few dependencies, including the Python dependency using PIP, and expose the 5,000 ports and running the script which runs the Flask web service. The Kubernetes and Docker will be installed using the tutorial 5 methods and in combination with the official documentation. I firstly install the Docker engine and test out using run hello world container, and then I install the adapter for the Docker to Kubernetes, and then I install the Kubernetes and altered a few IP roles. The Kubernetes and Docker version will be 26, and the Kubernetes version will be 1.26.4. And the network module we will be using is ViVNet, which is easy to deploy and manage and has a high performance, and it's including the security modules and has a great compatibility with other Kubernetes nodes. The cluster nodes will be listed here. There will be three cluster nodes. One is the mainframe, and there will be two workers, and they are all ready. And the deployment.yaml file is here, which creates a deployment called YOLO cluster, and it's using the YOLO API latest image on the Docker. The resource on each pod will be limited to 0.5 CPU and 512 megabytes of RAM, and the port on each node will be open is 5,000. The service will be called a YOLO service, and its selector will select the YOLO app here, and it will open the 5,000 ports on each node, and the node port will be 3008. Its type is the node port, as required, as shown in the tutorial 5. So the Docker image will be shown using this command. The Docker image is using we are using in the Kubernetes cluster is YOLO API, and its tag is latest. And the VMs we are using is one mainframe, two worker nodes. The IP of the mainframe, which is a controller, is this. and the mainframe is configured under a VNIC called virtual network called assignment, and it's under a security group called kubemaster, which actually provides the support, opens the ports for Kubernetes as shown here, and 3 ports for the VNet to be working, and they are all for the private network, and one public network is 80 port. There will be 4 ports configuring right now, and I will be showing, and there will be 4 ports, and they are all running right now, and I will be running a client request here on my local machine, and it will start to requesting the backend, which is a Kubernetes cluster, and I will show the logs on each port to show that they are actually load balancing, and I will be changing the node name to the actual node name right now here, and it clearly shows that it's receiving a list of requests, and I will be showing for another node to ensure that it's actually node balancing across all the nodes, and the requests are actually spread across all the nodes as shown here. And thank you, that's all for today.